then f is continuous, which we've already proven. That means that if f is not continuous, then f is not differentiable. Okay, so you have two different ones. You have either it's not continuous or it's a sharp corner. And the third one, let you finish writing that one. All right. And the third is that it's not differentiable if the curve, I was about to put graph, I guess you could say graph, has a vertical tangent. Okay. What you mean by vertical tangent is, let's say, for example, if you have that graph here. Okay, so we know our slope here is going to be positive. We know once you get to the top, your slope is 0 because it's just a straight horizontal line. And we know here your slope is negative. But if you get a point, let's say here, where you have a completely vertical tangent line, then it's not differentiable at that point. All right, so any questions on this one? All right. So for this section, most of the problems are in the form of graphs, so we're going to just look at a few of those. Yes?
Is there an example of a function that actually has that? Vertical tangent line?
Really, any function where you have a, I guess you could say a y squared. It's kind of like, because if you think about it with vertical line test, if it doesn't pass the vertical line test, it's not even really a function.
Right.
So
because if you have no change in x, how can you have a change in y?
Exactly. So that's why it wouldn't exist, because it's not differentiable, because you have basically a non-function. But they actually do cover that in, I want to say Calc 3. I think it's Calc 3 here. It might be in differential equations in another class, but parametric equations. That's when they start to dig into those. So it does come up. You just don't have to worry about it just yet as far as like vertical tangents. Okay. Any other questions? All right. Okay, so it was, had to do a lot of shrinking, so I'm not sure. There we go. Okay, so which functions are differentiable at x equals 3? And they actually have those 4. Okay.
Third one? Or not third one, second one?
Yep, the second one. Because here, that's where you have your vertical tangent. Okay. And the third one, here you have that sharp corner. So you know it's not differentiable there. And this one is not continuous. So you know it's not differentiable. Okay, so this one's the only differentiable one there. Yes.
So when it's differentiable, does that mean like you can take the derivative of it, are you saying?
Yep, that the derivative of, let's say the limit of, let me write it out, because if I try to say it, it'll really sound horrible. That f prime of a is equal to the limit of f of, you can say x plus h or f of x minus f of a all over h as h approaches 0. It actually does exist. Okay, so okay, so if that limit exists, then you know it's differentiable.
Okay.
Okay, so we know here, like I said, just the simple fact that it's vertical, it's technically not even a function. And here we know that if you approach it from the left and right, that really quick turn keeps it from having any type of differentiable value at that point. And that one, it doesn't even exist at 3, so we know that doesn't exist. I mean, that's not differentiable. So this is the only one out of those 4. All right, so let's look at another one. Okay, and let me zoom out a little bit. Want to know why this function is not differentiable at x equals -1. And as soon as that moves out of the way, there we go. Yep. It has a corner at the point. So when it has that immediate turn, that corner, that's when you know it's not differentiable. Okay, so you'll get like a series of these graphs that you'll have to answer questions for. So like I said, we'll go over a couple of them. Okay. Now, why is that not differentiable? Yep, not continuous. It goes from one end and picks up and goes to the other. Okay, so that one's not continuous. Okay, now with this one, we'll bring that down a little bit. It's basically giving you the idea of, I guess you could say the concept of a derivative is where you have your positive slope. Your slope is equal to 0 when it's horizontal, and you have your negative slope when it's going down and to the right. So we know at A, without even knowing what this graph is or the value of A, we know one thing, that f prime of A is going to be negative. Because the slope of everything from this point, let's say x equals -2 all the way to 0, is going down. So you know your slope is going to be negative. Okay, so we know that, let's say f of x is decreasing at point A. So we know that f prime of A is negative. Oh, probably should have put that on the next line. So f prime of A, thank you, is negative. Okay. Now when you get to B, just like with any other slope, if you have a slope of 0, then it's just a horizontal line. So if you have your well, it was supposed to like barely touch that circle. But when your slope at that particular point is 0, then your f prime of b is going to be 0. So move that up some. Then of course c is increasing. So you know if it's increasing, then your slope is going to be positive. How can we still hear him through the door? Oh, point C. So we know that f prime of c is positive. All right, so any questions on that one? All right. Okay, so let's say if we have f prime of x, well, f of x here. And we want to know which interval is this function negative.
Infinite, or 0 to infinity.
Yep, 0 to infinity. So we know that f prime of x is negative on the interval zero to infinity. Okay. Now we know it's not negative right at 0 because it's always use this as like the throwing a ball comparison. If you throw a ball, at some point it's going up and up, the slope is up. Then at some point it hits its top. So that's when basically your rate of change is 0, and then you have a negative slope on that one. So this one kind of has that same arc. All right. Okay, so any questions on this one?
So, so that slope would be, you said it's negative from 0 to infinity.
Mm-hmm.
I'm just trying to figure out, like, just by looking at the graph, that's going,
Yep.
that's going downwards.
Yep, because it's decreasing from here. So you know the slope of that is going to be negative.
Okay.
It's kind of like if you remember the linear formulas where if you have y equals 2x plus b, let's see. Let's say if you have y equals mx plus b.
Yeah.
So if you have y equals negative 2x plus 5, you know since that slope is negative, that it's going down and to the right. So this is the exact same thing. If it's going down and to the right, it's negative. If it's going up and to the right, it's positive.
But what, and same thing was going down to the left, it's still negative, correct?
Oh, then you're just going in the opposite direction. So as x increases, then if your y increases as x is increasing, then it's positive. So here, as x is getting bigger and bigger and bigger, your y is getting bigger and bigger and bigger. So that's why it's increasing from negative infinity to 0. Then as x keeps getting bigger, once you cross that point, y is now getting smaller.
So to put, if you were doing it from that side, it would be negative infinity to 0.
Yep, exactly. If you were looking for the positive.
Right.
Yeah.
Okay. That's what I was having a hard time understanding both
Yep.
sides, so.
Yeah.
That's specifically like that f of x, it's basically f of x
Mhm.
equals negative x squared, is it right, or is it?
Oh, it could be. We have no idea what this actually is. They just tell you f of x. So it's more along the lines of being able to recognize, which part is increasing and decreasing.
For graphs that.
Yeah, it looks like it's negative x squared, so
Right,
probably is, but they just call it f of x.
okay.
So for this one, they want to know what's the sign of f prime of x at x equals a.
Positive.
Yep, you know it's positive just because it's increasing at that point. Now if it was over here, it would be, of course, negative, just like the last one. So you know here it's positive. All right, so let's say if you have this one here, and they wanted to know over what interval is it positive? Is the slope positive?
0 to infinity.
Nope, actually would go from,
Negative
yep,
infinity to positive.
yep, negative infinity to infinity. Because you notice here, it's increasing from here to here to here. It never levels off.
Oh, yeah.
It just kind of, I think this is probably the f of x equal x cubed, but who knows? But it just kind of keeps increasing. So here, since it's always increasing, f prime of x is positive on negative infinity to infinity.
So if it does more of a curve like that and then like that, then it would be.
Yep.
That's it.
So if it went up and then it leveled off for a little bit and then went up again, that's when you know it would go all the way until it started to level off. And then once it starts to go back up again, it would just chop it up into those two.
At that point, it's non-differential, right? Because it levels off.
Oh no, there it just has a slope of 0. Yep, only if it
Oh,
went,
vertical.
completely vertical. Yep. 0 is just fine, but vertical is not.
So basically, when it, like, because I know that we talked about having like a sharp corner before
Mhm.
it turns, if it has that.
Oh yeah, if it has a sharp corner, then it wouldn't be at that point. So it would be differentiable from, let's say, negative infinity all the way to that sharp corner. Then it would get on the other side and pick back up.
Now, would it be negative at 0, negative infinity?
At 0, negative infinity. No, that would be, on this one, it would be positive.
Right, but what if you go the opposite direction,
Oh, if you go in the opposite direction, then
which is 0?
you're now decreasing your x value instead of increasing.
Oh, okay.
Yeah. So your x value always has to increase
Right.
to find out the rate of change. Uh-oh. All right, does that make sense? No. Okay. Okay, so what about this one? They want to know which intervals is the rate of change or the slope positive. Okay, so we know here that it's increasing on that interval. And we can, it looks like that is probably the,
Looks like a negative 1
oh,
right there.
oh, negative, I'm sorry.
So that
I'm
should
reading
be-
positive, so it should be negative.
So you should have negative infinity to negative 1 and
Yep.
2 to infinity.
Yep, so it's decreasing there and there. Yep, so from negative infinity to negative 1, because that's where it levels off and starts to go back up. And from 2 to infinity.
And that would be something you pick 2 or not just 1.
Hmm?
That would be something you pick, select all that applies.
Oh yeah, sometimes it'll be 1, sometimes it'll be 2. It all depends on the graph. All right, so any questions on this one? All right. Now with this one, what they'll have is, they'll ask you what's the actual value, let me straighten that up a little bit, of f prime of 2. And with that one, you just go right back to the formula for slope. So you have your x2, y2, and x1, y1. Because remember, your tangent is just that straight line. Or if you wanted to, you could use the the formula.
X plus H and all that.
Yep, exactly. So if you want to use the limit of f of x plus h minus f of x all over h as h approaches 0 to find your f prime of x. You can do that too. Because remember, this is your x and your f of x. And this is your x plus h and f of x plus h. Because remember, you're going to the right for your x plus h. Okay? So if you're, let me see, let me rewrite it. -2, 1, and 0, 5. That's your x, f of x. And that's your x plus h, and your f of x plus h. Okay, so that just gives you the limit as h approaches 0 of f of x plus h minus f of x, so 5 minus 1, all over x plus h minus x, or your h, -2. Okay, so you end up with the limit of 4 over 2, which is just 2.
And you said we could do the same thing, the y2 minus y1 over x2.
Yep, if you're just looking for the actual value of that slope, all you have to do is pick 2 points and plug in the old m equals y2 minus y1 over x2 minus x1, because really that's all the slope of the secant line is. It's just a plain ordinary formula for slope, but just written a little bit differently.
So you only get 1 point instead of 2 points. Let's say
Oh, they only give you 1 point? Then actually on some of them they don't give you any points. So all you have to do is just follow the line and pick any 2 points along that line and do the same thing. All right. So any questions on this one? Oh, sure. Mm-hmm. Okay. Now this one is a little bit tricky because they want you to actually graph the derivative. And with most of them, they'll give you like 4 or 5 options. Okay. So I'll give you some pointers to kind of look at. So the first thing you want to do is always look at where the slope is equal to 0. Okay, so this is where your slope is equal to 0. Okay. Slope is 0. Well, I might as well say derivative is 0. I actually use the right terminology. F prime of x is 0. At x equals -2,